A car dealership has 24 feet of dividers with which to enclose a rectangular play space in a corner of a customer lounge. The sides against the wall require no partition. Suppose the play space is X feet long. So a diagram here would be helpful, and we have a corner right here that we want to partition off. So I have a wall, or actually two sides against this wall, and I have the partitions, just two of them that I need to put up against the wall. So I have 24 feet of dividers, and the play space is X feet long. Well, since I don't have a partition that's also X feet on the other side, then the other dimension here is just one other side, and that's just going to be 24 total feet minus X feet. So the area in terms of X, A of X, is length times width. So for this it would be X times 24 minus X. And if we cleared parentheses, we would get 24X minus X squared. Find the domain. The domain lists the possible X values that you're allowed to use for this function. So in real life, you can't plug in every number like negatives and positives. Sometimes you have restrictions, and for this, X represents the feet of the dividers. And so it obviously can't be negative feet, and it can't be 0 feet. So X must be greater than 0, and X is limited to being 24 feet. So putting that together gives me 0 is less than X is less than 24, or the domain as an interval would be 0, 24 with parentheses. So now we have a graph showing the function 24x minus x squared graphed, and it is a parabola. It's a U-shaped graph facing down, and notice that the high point, or the maximum point of the graph, is plotted, and it's 12, 144. So using that, determine the dimensions that give us the maximum area here for this play space. So it's helpful to list what the numbers in the ordered pair actually stand for. So the 12 is the x coordinate, and x is the feet, that's the length. And then the 144 is a of x. Normally it's x comma y, but for our area that we graphed, it's x and a of x. So using 12 feet for the length, we're going to maximize our area of 144 square feet. But those aren't the dimensions of the rectangle. So what we need to do is maybe look at our diagram up here, and we want to pick 12 feet for the length. So then our other side was 24 minus x, or 24 minus 12. So 12 feet is going to be the dimensions for the width. So we want to make a 12 by 12 partition to maximize the area.